Welcome everybody to the W3C ORTC Community Group Meeting number 8, May 13th, 2015. This meeting will last for an hour and a half, and we're running on Pacific Daylight Time. Special attention to the CG IPR policy. Here's a link in the slides, which were also posted to the W3C CG site. And here are some goals and essentially how it works in practice. You can post to the list, and you can read this at your leisure. Since we're a bit pressed for time, I'm going to kind of skim some of this stuff. Now 102 members. Yay! Can everybody hear me okay?
Yep, I can.
Okay. Here's a bit more information. This meeting link is incorrect in the slide deck. We've reverted to Chrome for this meeting. I think that's pretty obvious by now. The IRC W3C channel ORTC will serve for minutes. Can we ask for a scribe from somebody at this point? I'm a little busy running the deck and troubleshooting tech stuff here, so could somebody volunteer for scribing?
Emil, would you be willing?
Yeah, would you like me to do that in the IRC chat room?
Yes, please.
Can you just remind me the... Oh yeah, there you go, okay.
Great, thanks,
Sure.
Emil. Okay, this meeting is being recorded and will be published on the W3C CG Meeting, or CG site. Probably skip that for now. And here are some various links and mailing list information. Dev and API draft site ortc.org is a good launch pad for a lot of this stuff. The issues list and editor's draft changes. Okay, I'll hand off to Robin and Bernard.
Okay, so a couple of the changes from the previous March 25th draft. Actually, go back a slide. Yeah. So one editorial issue, we have the new grouping taxonomy draft, and it defines transport terminology like single RTP stream, single transport, multiple RTP stream, single transport. So we've added that to section 1.1. There were a couple of WebRTC 1.0 compatibility issues that came up. There's, I guess, it's more than a proposal, right? Replace track is actually going into WebRTC 1.0. And our equivalent is set track, and so we have made that a promise to correspond to replace track, and a bunch of the same language is now in there. We didn't have DTMF parameters and capabilities as specified in 4733, so we added that. In addition, there was a question that came up if somebody called sender.insert DTMF before sender.send. That would be weird because the DTMF codec wouldn't be specified, and so now an exception is generated if you do that. Also, it was pointed out that it was possible for somebody to call receiver.receive or sender.send with parameters.rtcp mux set to false. That is, I don't want RTP multiplexing, but not specify an RTCP DTLS transport so that the multiplexing could actually happen. And so exceptions are now thrown in those cases. Next. Okay. So a couple of DTLS issues also came up, and we'll go into those in a little bit more detail. But basically, the sequence of events is that once an ICE connectivity check is successfully responded to, it's possible for DTLS packets to arrive. And that can happen before DTLS transport.start is called, or even before the there's an RTC DTLS transport constructed or attached to an ICE transport. That's issue 173. There are also a whole bunch of situations where a DTLS transport, an ICE transport, or an ICE gatherer are in the closed state, and you try to do things like instructing other objects for them or calling methods and stuff like that. So the question is, when do you generate exceptions in those cases? The third one is the exact meaning of the DTLS transport states, like what exactly can happen in each state. So a little bit more about those. Next. Okay, so issue 173 is what happens when DTLS packets arrive before DTLS transport got start. So as I mentioned, you can get incoming DTLS once you've sent a successful response to a connectivity check. The proposal is for the ICE transport to buffer those incoming DTLS packets prior to construction so they don't get thrown away. But then some questions arose as what exactly happens. So before you call start, the proposal is that the DTLS transport, if it actually gets the packets, so you've constructed it from an ICE transport and so you have the pipeline, it should respond to them, but before you call start, it doesn't have the information to verify the remote fingerprint. And so the proposal is that the connected state, you can't get to the connected state before you verify the remote fingerprint. So we'll talk a little bit more about that in the state definitions. But you can get this incoming DTLS and potentially respond to it before calling start. Next. Next slide, Eric. Nope, back one. Okay. So 186 is handling of objects in the closed state. So we looked at a bunch of the situations where you could have an object in the closed state pass as an argument in a constructor or method. So here are some examples where we think that an invalid state error should be thrown. So if you attempt to construct a DTLS transport from an ICE transport that is in the closed state, that will throw an exception. If you call DTLS transport.start and the DTLS transport was closed, that will throw an exception. If you call ICE transport.start, if the gatherer is closed, that will cause an exception. And if you call ICE transport.add remote candidate, set remote candidates, or create associated transport, if the ICE transport is in the closed state, that will also throw exceptions. So perhaps the more interesting question is, when don't you throw an exception? So at least right now, if you call ICE transport.stop, if you're already in the closed state, that's kind of a no-op, so no exception there, right? Just it remains closed. But also, we looked at get remote parameters, get remote candidates, and get nominated candidate pair, and what happens if the ICE transport.state is closed. And so at least right now, it's proposed to operate normally. So you will return the remote parameters or the remote candidates or the nominated pair, even though the transport state is closed. Any comments on that? Okay. So a little bit of clarification on the transport state definitions. So the first thing is, as we mentioned, you can't get to connected until you verify the remote fingerprint. And so it doesn't make sense to be sending outgoing media before that happens. So basically, you have to wait until you get to connected to send outgoing media, and that requires remote fingerprint verification. So far, so good. The problem is that in an offer answer, the answerer can verify the remote fingerprint before the offerer gets the answer. So a conclusion is it's possible to receive income media in the connecting state. So in other words, before you call DTLS transport.start, you actually can get incoming media. Because basically the remote peer verifies the local fingerprint. All right, it goes into the connected state, and now it can send media. But the local peer has not verified the remote fingerprint yet because the answer hasn't come in. So it can't call that start. So there is that kind of weird asymmetry. And we'll talk more about some of the implications of that. Now, it's a little bit easier to deal with is how do you get into the closed state for DTLS, and that's if you call stop. Or alternatively, if you call stop on the ICE transport that the DTLS is constructed from, that will also bring the DTLS transport into the closed state. So Robin will talk some more about some of this implications of receiving DTLS packets before even calling that start, because that's a little bit weird. So some other ICE-related issues, and that's a theme during this meeting. We'll be talking a lot about ICE, so a bunch of stuff, issues related to that. We added a closed method to the ICE gatherer. And that, if you call icegatherer.close, that prunes all the local candidates, and also the associated ice transport objects transition to the disconnected state. We had some questions about the behavior of TCP candidate types, and so the advice was that browsers must gather the active TCP candidates and only the active TCP candidates, right? But the servers and other endpoints may gather active, passive, or SO. A little bit more about behavior of RTC icegatherer.onLocalCandidate. So there's a question about what happens when you gather your final candidate, and how you signal that, and also what happens with add remote candidate. And so the idea is that when that last candidate is gathered, it emits an RTC ice candidate complete. So on local candidate, actually there's a special dictionary that is emitted when you have the last one. And so you can serialize that, send that to the other side, and then when you call add remote candidate with that as an argument, the RTC ice transport can't enter the completed state. So those are the proposals for these.
Does that dictionary argument contain any information?
Not right now, no.
Yeah, Bernard, you meant it can enter the completed state at that point, right?
Can enter it, right. It is kind of off, yeah, it doesn't mean it does, but it can.
So is it like a bool on the candidate? Like candidate.complete, or?
Right now, there's nothing in the dictionary. We might need to define something just to have some kind of property in there, but we don't have anything right now. It's just an empty dictionary.
So
Yeah,
just its presence, not
now
being...
have something that can be serialized and signaled and sent across, not just a null.
It probably needs to have the MID or whatever. Like, is it, if we're gathering? I think there was some condition where if you're gathering for multiple M sections, you might need to send end of candidates, for different M sections at different times. So it might need to indicate like when each group of candidates that's trying to gather is complete.
You want to multiply the gatherer for this, or actually do you want to do some gatherers?
Yeah, it's so it's kind of weird, right? Each transport, right, has its own state. So it's like
Right.
each M line having its own weird ice state.
Right. So if you have multiple gatherers and one for each of these, then I guess then that solves the problem because each gatherer will complain on its own.
Yeah.
Yep.
So I think the takeaway here is to investigate whether we need some kind of value inside of this dictionary or not.
Right. I think that the sample code would probably make it clear whether this is actually needed or not.
Right. We don't have any sample code related to this right now.
Yeah, because it's an empty dictionary, but presumably they might have like a one attribute inside, like completed, and it's always set to true or something like that.
Yeah. Probably file. Emil put in there. Probably file an issue on this.
Yeah, I'd like to see some sample of what it looks like.
Yeah.
I had a question regarding the transports and the closed states. So if it's possible to receive data before we call start, is it possible to still receive data after we call closed?
No.
So how is... sorry, I'm actually a little bit new to the ice transport, but how we're closing locally, so how do we know the remote side is not going to be sending data anymore?
We can't control what the remote side does. We can only control what we do locally. But presumably it wouldn't be wired to any sender or receiver at that point. Nothing would respond. So consent would be dropped.
Close means close the local ports as well. Then that means the packet will reach local machine, but will not be delivered to the RTC. Is that the case?
Yeah. So Jianan asked, like, what exactly does close mean? Does it mean the port gets closed, or?
No, it doesn't, because the port is opened by the gatherer, which in a fork scenario could have multiple remote parties attached. So if you're closing,
just talking about ice transport.
yeah. So for the Yeah, for the ice transport.stop, presumably that would just stop that particular responses to that particular username fragment for the remote party, and consent would be dropped there. But it would not affect any other forks and would not affect the ports because the ports are controlled by the gatherer.
But calling icegatherer.close would close the port, right?
Yes.
And how about the DTLS transport?
A DTLS transport is attached to an ICE transport, so if you close the ICE transport, the DTLS transport would have to close as well because it's directly constructed off of that ICE transport.
So that will transition, calling iceTransport.close will transition the DTLS transport also to close state.
Yep.
No, I was actually asking what if you call DTLS transport.close?
That's a good question. Now, there are buy packets that are sent, I believe, for the DTLS, but they don't actually officially remove consent. So there is still a bit of a concern in terms of can you construct a new DTLS transport after the first DTLS transport is closed. And the presumption here is that, yes, you can. But I don't know if we actually want to allow that and what all the implications are. So I don't know. That's an open, outstanding issue.
So is there another issue to be opened, I think, maybe?
I think we might have one, but if not, we should open one to investigate what we should do on this scenario. Okay. If anybody's got any feedback, it's welcomed.
So I had a question about the DTMF stuff, issue 177.
Yes.
So this sort of seems like an anachronism here. What's the need for actually surfacing like which DTMF information needs to be supported by the remote side?
Well, in the SDP, right, you actually advertise the events that you support in the offer answer. So the question is how you would construct that SDP if there was no way to get that capability.
Yeah, I mean, I feel like since we don't actually act on any of these events, that like we would just omit that entirely.
It doesn't affect anything in the API, but I guess that's a good question. Like, what would you? Well, we do. It is proposed that you have capabilities and settings. So I guess you advertise your capabilities, like what events you support, and the other guy could come back and say, I don't support some of them, and then you could set, some of those things off. Is that actually ever done in W3C 1.0?
No, I mean, I think we had a similar discussion on this on 1.0 and decided that since you don't ever process incoming DTMF, like this is really an application-specific concern, and you would need really something from the other side to say, okay, what buttons should be lit up, and those would all have to be surfaced through some other mechanism that really would be could be done by the application very easily. It's not clear that what that goes on the wire would ever change as a result of like any of these settings or anything. So it just seemed I wasn't quite clear when you would ever use this.
Yeah, maybe I just don't understand the SDP well enough, because I was thinking maybe you say I'm capable of doing this, and the other guy says I don't understand these events. It's not that you're receiving them; it's just the other person saying, hey, I don't get this, so don't send this to me.
Right, but then like how would that even be exposed outward from the API? I mean, like. Yeah, there needs to be some way in the application to read like what is the remote side support and disable the buttons correspondingly. And since there is no API, you would just have these things where someone would push a button and we would just have to eat it inside the implementation, which hardly seems like it's like a significant improvement over the existing state.
Yeah. Although, I remember the SDP line there, at least which event you support, but I never see anybody really negotiate like. Right. Only send 0 to 8 and not 9.
Just a quick jump in here, Bernard. I'm not sure who's with.
Hello, Emil.
You don't hear me? Or?
You broke up there. Retry.
Okay, I was saying I don't know who's with Bernard, but I have a very hard time understanding what they're saying.
And that was
I could get close to the mic.
Yeah. So Jianan was just saying that, basically agreeing with Justin, for what Justin said, that. Typically you don't negotiate this really in SDP.
So is the takeaway that we don't need that in the API?
Yeah, Jianan says he thinks we don't need it.
Since we hate the events and the default implementation anyway, I don't see why we need to expose it either.
Okay, we can take that out. Okay, so write that down in notes. Doesn't seem to be needed.
Okay, yeah, we've captured that in the minutes. Thanks, Emil.
Sure.
Any other questions about the
Buffering?
general aspects of the spec?
Yeah, I had a question about packet buffering.
Uh,
So we talked a lot last time, or previously, about the ice transport and trying to make it, or rather the ice gatherer responding to stun binding requests, but not do buffering. So did we ever decide to include the ice gatherer as one of the arguments in the ice transport constructor? I know there was we discussed that a
So,
lot. Did we ever
Robin-
advise on that?
Robin will be talking extensively about that in a minute.
Yeah,
Okay.
I've actually got a bunch of slides on this, and I wanted to bring it up to the group because we have not found a complete solution, unfortunately, to the problem. There's always one little gotcha that creeps up.
That part thing turns out to be way more complicated than we initially thought.
Right, and a big part of that is to avoid the buffering of packets.
Right.
So, in a similar vein, I think we would want to avoid having to buffer packets in the case where the DTLS packets are coming in.
I completely agree. I'm not sure the solution yet, though.
Okay. Well, I think we should probably not finalize the decision on buffering DTLS packets until we've figured out the ICE part of it.
Agreed.
Yeah, they're all related, unfortunately. It's this big tangled mess of bugs.
So we're gonna
Okay. Are we going to be talking about that later,
yeah,
anyways?
we're gonna
Yeah,
cover.
we're about to get into the next level. of the-
I-
Before we jump down the rabbit hole, I had one other question, which is in a slightly similar vein. Before we verify the remote fingerprint, is it so bad to receive media in a slightly unverified state, if only for a little while? I mean, I can
don't-
understand not sending it, but
I don't think so because the remote party, from their perspective, has verified. So they do trust you. You just don't trust them yet.
right. So I'm asking, how bad is it to
Personally, I don't think
play
that's
out media or view media for a limited period of time before we've verified the remote?
I don't think it's bad from a receiving perspective because it's up to them what they choose to send in that state and whether they trust you. You're not sending to them, so you're not leaking anything, and they're leaking to you, but they do trust you. So from their perspective, everything's fine.
Yeah, but I wouldn't want that to be going on for more than a certain limited time period at least, because I wouldn't want to be in a situation where I think the other side is who I think they are, and then I'm receiving media that's not verified.
If remote verification fails, the DTLS transport will transition to the closed state, and then you can't get any incoming media.
Justin, you're muted.
You can imagine that an attacker could try to delay the delivery of like the actual handshake or the actual signaling packet, and then make that state exist as long as they want it to. The case where
Right.
that fingerprint has not yet been verified. So it definitely seems like a very corner case. But if someone wanted to man in the middle, put in their own fingerprint and then play at their own media. The problem is that this creates for the application a gray area where it's like, oh, there's some cases where I can receive media, and some cases where I can't receive media, or I can receive media and know it's secure, and some cases where I can receive media and it may not be secure. And I think this is hard to really indicate in the sensible kind of way to a user that, well, there's these sort of shades of gray of security here.
For the notes, exactly how many shades of gray?
50?
No, 51, something like that.
Thank you.
So, yeah, in Seattle today, so very apropos. I think the easiest thing is just say, well, for keyframes and media that really we don't want to drop, it's okay to buffer, but we really should never emit it upwards to the application until we verified it. And that sort of avoids the issue with, well, I lost the first keyframe packets, and now I need a RTX or something like that, then my call starts off in a bad way. But it never has any. It allows the security guarantee from the stack to the application to always be very clean.
But in the case of audio, would that mean your audio is going to be clipped until it gets verified?
Yeah, it would be. Well, yes. I mean, let's just say like the simplest thing is just discard all audio until you actually get to a verified state. I don't think this actually can happen, though. I forget exactly why, but I think the main thing is you can't start the ICE checks going outwards until you get the remote answer. And so the chance that you can actually achieve connectivity and you actually have media clipping, at least in the initial call setup, is actually quite low.
But you can't send that. You can't send surely, but yeah, it can theoretically come in, right? Incoming.
But only in really rare cases where you have like a cone NAT or something like that, because what's probably going to happen is that your pinholes for media won't be open yet.
Right.
Because you haven't yet set any ICE checks going outward from your source. Yes. So only in edge cases will this even be possible, and then it's a timing race anyway. I think this does not affect the vast majority of users.
Mm-hmm.
And it's usually the answerer who says hello and not the person who's calling out anyway. So
yeah.
It's probably at least in telephony scenarios, it's fine.
You've obviously never tried calling my kids, but yes. Oh, you called me, yes. But yeah, agreed.
Yeah, and that's a good point. And that's going to play actually into issue number 170 as well, when we talk about responding to connectivity checks and the buffering problem there. So.
Okay, so is our conclusion here that we should, at least for now, we should have a very clear security policy from the application, or from the stack to the application, where you only get media that's secured. And if something arrives prior to it, the fingerprint being verified, we can hang on to it for some finite period of time, just so that we can get the decoder in the right state.
So we can receive it in connecting, but we won't pass it on until we get to connect it. I guess what we're saying.
Yeah.
We're not throwing it away in connecting, but.
I think we're saying the audio is basically thrown away, but video iframes will be retained.
Well, I think what we might do is we might decode it, but not emit it, if that is even possible, or hold it for future decoding. But like that stuff would just be used to initialize decoder state,
right?
And not push upwards.
At this time, we may not be able to differentiate audio or video RT packets, so permanent checking may not be able.
Yeah, it depends until you call receiver.receive, right? You don't even know what the kind is, so it's a whole nother issue. Yeah. So anyway, Robin, why don't you go ahead and dive down the rat hole?
All right. Let's go to the next. Okay, before we go to the next slide, items for discussion today is the ice gatherer pruning. We've discussed this before. Had a little personal flip-flop on my opinion on it, but just like to present it to the group and decide what we want to do there. And then related to the DTLS buffering that can come in, whether we want to allow incoming connectivity checks to be responded to from a potential transport before actually calling the start method, so that incoming ICE checks can actually be responded to immediately, and I'll get into the slides on that. And we discovered that priority calculation is not possible without the component on the gatherer, and we'll discuss that as well. So next slide. Coming stuff we want to discuss. We wanted to discuss today, but we figured there wasn't enough time, and I'm glad we cut it. This has to do with sender and receiver parameters and how to properly latch. We've already written some stuff up on that into the ORTC specification, but we haven't presented it to everybody here, so that's going to come up in the hopefully next meeting. And obviously any changes from WebRTC 1.0 that come up will reflect it here, and we'd like to get the stats API getting up there as well at some point. Next. So the issue has to do with the ICE gatherer. The ICE gatherer is responsible for gathering host, server, reflexive, and relay candidates. But what's not clear, especially in a fork scenario, is when you can prune those candidates, when the gatherer doesn't need to maintain them and can drop them off because there's no other answer possible coming in. And from an ICE gatherer object perspective, you just don't know because you don't have enough sufficient information inside your own object to know that something else might respond later. If you prematurely prune candidates, incoming ICE connectivity checks from some remote transport might just get ignored, and effectively you can't establish communication, which is bad. But if you don't prune your candidates ever, then you're wasting firewall ports or turn resources, and the worst is actually keeping the wireless WAN interfaces warm, which can cause your 3G, 4G interface to be kept alive at all times and killing your battery needlessly on a mobile device. So it's very important to prune those candidates. Next slide. So one suggestion has been that you pass into the ICE transport the gatherer, and the presumption here is that if the ICE transport isn't in a final state, meaning it's either in the failed or completed state, basically the gatherer should not prune until all attached ICE transports are in that state. And moreover, it allows you to do some little trick, which is that you can keep the gatherer permanently warm, or as warm as you like, for as long as you like, by just keeping one additional +1 ICE transport attached to the gatherer, and by default then the gatherer is therefore warm. I actually like this solution a lot, but that's my personal preference, and there's going to be two options presented here. And this is where I flip-flop, because I actually like the other option initially first, but I like this now. So to recap here, the ICE transport is constructed with an ICE gatherer passed in, and so long as any ICE transport attached to an ICE gatherer is not in the completed or final state, then don't prune those candidates until they all are. This requires that an ICE transport can accept an optional ICE gatherer during construction prior to calling start, because right now an ICE transport does not take an ICE gatherer until you call start, and you can't call start until you have completed signaling, and the presumption here is that you might have outstanding answers that do not come back from forks. The nice benefit about this is that you automatically prune from your gatherer based upon the transport state attached, so your programmer really doesn't have to do anything special. All the programmer has to do is keep a nice transport and not in the final state to keep things alive. And the only drawback is that now we have to pass in an ICE gatherer to the ICE transport constructor, which I don't see as a big drawback personally, but that's that. There's another.
Before you move on, can I ask a question?
Mm-hmm. Yeah.
So if we create an ICE gatherer and never attach an ICE transport, does it just stay? Does it never prune until an ICE transport's attached?
Don't know. That's kind of an outstanding issue which we have, and I presume that until you attach your first one, the answer would be yes, because otherwise it seems a little bit weird. Because of construction order, you have to create the gatherer before the transport, and that creates a little tiny race window. And if your implementation was really fast, it could create and prune almost instantly, which seems a little bit strange. So my gut feeling is that yes, that would be true.
Emil, I think maybe note that there is a potential issue that Peter just raised.
Done.
Yeah, there's a race window which constructing a
Well-
gather before a transport.
Robin's response was what I was thinking also, which is basically if I created a nice gather out and by itself and I never attach anything to it, I would kind of expect it to not prune.
We don't say that explicitly, so.
Yeah, but we do need to say that explicitly in the spec if that's the case. So the other possible solution to this problem is to just make it completely explicit, where you have a method inside the ice gatherer like set keep alive, and you set true or false. And while you're in keep alive state, it doesn't prune, and the moment you go out of keep alive state, it's allowed to prune. So there's an example of usage there. And the same problem exists that Peter mentions as well. It's what state does the keep alive default to when you construct it? Presumption there again would be that it would have to be in the keep alive until you turn it off because of that same reason. So next slide. Again, this is where we add an explicit method. It's very clear when it's pruning or not. That is the benefit. The drawback is that your programmer is required to do something, otherwise candidates may never get pruned at all, and I can see a lot of bugs coming about because of this. And again, you don't want to prune as much as you can to not consume resources or battery life as much as possible. So not so keen on that. So the question.
So if you call set keep alive false, basically any candidates that are not currently in use by a connected ice transport get eaten. Is that right?
Correct.
Okay.
Yeah, that's the presumption.
And the automatic one is based on, is there any, if there's, can this only get pruned when there's an ice transport that is not, when all ice transports are either in the connected or in the connected state, that if there's any ice transport that's not in the connected state, then pruning cannot occur.
In the completed state. So until it's final, yes.
Right.
Yeah.
Okay. Carry on.
So the question for everybody here is either solution acceptable? Is there a preference? Is it worth doing this additional effort? We do need some kind of answer to this in the spec. So what do we do? And I'm just putting it out there at this point. What do people like?
I like the first.
Yeah, so do I.
I think in order to do the responding to stun binary requests, we need to pass in the gatherer to the constructor anyway. So, and it's a lot more. I don't know. The other one seems like very easy to do wrong, and the other one seems like very easy to do right.
Yeah.
I like the first as well.
I agree.
So it sounds like we have consensus. Does anybody object to this solution? The first one, which is passing it in the constructor? Doesn't seem so.
Just a quick question, nothing to do with the consensus here, but we aren't actually talking about the 5245 pruning, right? This is basically garbage collecting ports and all that?
Yes.
Okay. So maybe we should use a different term just to avoid confusion.
Does 5245 have a prune? What does prune mean in 5245?
Candidate pair pruning.
Yeah, it's when you're creating your candidate lists.
Yes.
You're dropping some of the candidates there.
Agreed. Okay.
Yeah, so maybe we should
Some of the candidate pairs, right?
Yeah.
Right.
Yeah, pruning has a specific meaning, just like freezing does for that, and it's a good point about confusion. So maybe we should call it garbage collection or something like that of candidates. Okay, let's make that. Would you mind making a mention of that, Emil?
Yes.
Thanks in the notes. Okay. All right. So the next, so we're switching gears here, and this is kind of related, and we did this in a particular order for purpose. So this particular scenario is an issue. What happens when you create a gatherer, the moment you create a gatherer, ports are being listened on. So at that moment, at any time, because you can get your username and fragment, your username fragment and password out of the gatherer, you could send it to a remote party, and therefore they can issue connectivity checks to you. So at any moment after you constructed and obtained that information, you can start receiving ICE connectivity checks. However, there might not be any ICE transports there with the start method having been called. And the start method is where you pass in the remote UFrag and remote password. So you know the remote guy. And it's really nice if we can to avoid buffering those incoming connectivity checks that come in until the start method isn't called for several reasons. One is to avoid the whole buffering to begin with, which is kind of nice. The next thing is it avoids a little bit of setup time because you can respond as early as possible. The other nice thing is that it correctly indicates the round trip time, because if you were to buffer the incoming checks for a period of time, you might incur additional round trip time in the calculation that doesn't really exist. So being able to respond immediately is important. It also it has some drawbacks and some benefits too, in the sense that the moment you do respond to an activity check, DTLS can start arriving. So if you do respond, you have to have DTLS ready, and potentially you could receive media as a result of that as well. So you have to have your media potentially set up. And again, this is, has to do with the fingerprint issue. So I just want to mention that it is nice to be able to respond to connectivity checks. Next slide. So I think that I just already covered this on the previous talk, so I just think we're going to skip over that. Oh, no, I didn't. One little point at the end. It's the only issue with responding connectivity checks, and the only problem with being able to do it from the gatherer, is that if you don't know the role that you're supposed to be in for your transport, then what can happen is you might incorrectly respond to the affirmative that, hey, everything's fine with a connectivity check, but you were instead supposed to have responded with a role conflict in your ICE transport. So there's a bit of a problem there. So you really do need to make sure that you have the correct role, otherwise you're not allowed to respond. And so that creates a bit of a challenge. And how do we respond beforehand if you don't have the role set up properly? Next slide. So one possible solution, and this is related to the previous thing, is that again you could pass the ICE gatherer to the ICE transport in the constructor, and by doing so the ICE gatherer could say, hey, is there any ICE transports attached that who have not yet called start on them? And if so...
Question, Robin.
Yeah.
Do you mean the ICE gatherer to be mandatory here in the constructor, or would that...
No, the presumption again is it could be optional. That is just an oversight. Although we could make it mandatory, that's a separate issue. But again, the idea here is that you can create an ICE transport, attach it to your ICE gatherer, and your ICE gatherer could say, hey, I'm going to auto-latch any kind of remote username fragment that comes in to an unattached transport. And so you could have this remote username fragment DOM string automatically get filled in, as well as the role automatically get filled in, because you can base your own local role based upon the opposite role that's coming in from the remote party. And you could even emit a little event saying, hey, we're latched at this moment to a remote transport. I don't know if we actually have a use case for having that event or not, but it is theoretically possible to emit it. And the example is very simple. You just construct the transport with the gatherer, and you can even set up your DTLS then, and you're basically got a full pipeline set up before you have even potentially received your check. So, next slide. This is again what I just said, so this is just describing what I said, so let's just skip this. There are two problems though with this scenario. And the first problem seems like a small problem, but it exists. There is a tiny, tiny window between which you've constructed your ICE transport, and therefore connectivity responses can become automatically latched to your transport, but you do not yet have a DTLS transport attached. So it's possible that you could respond to a check, receive remote DTLS, all happening before you even constructed your DTLS transport. It's a very, very small window. In practice, probably will never happen, but in theory it can, so I wanted to mention it. And the other problem is even a
just a quick question here. Isn't it a very small window only if the programmer calls it in that order? That is, it could potentially be a bigger window if the programmer does it differently.
Yes. If the programmer doesn't do it in this particular order, it's a bigger problem. So yes, that's true.
The DTLS transfer constructed off the ICE transport, not the gatherer.
Oh yeah, that's a mistake. Sorry. DTLS transport should take an ICE transport, not the gatherer. It's just a silly typo. But yes, you're right, Tom, Emil, that it's a much bigger window if you don't construct it immediately afterwards. The other bigger problem is that
that's, I guess, the reason why you have to buffer the stuff, right? Because even
that's right. You still, because of this window, you still have to buffer potentially, which is what we're trying to avoid in the first place. But there's an even bigger problem in that if an ICE transport can automatically latch, there's no exact point when it's going to latch. You don't know, and it could have latched to some other remote username and fragment than you intended, because there's no designation. Like if you created a whole bunch of these transports in advance, there's no designation that a particular transport gets filled in with a particular username and fragment. So you could be calling the start method with a remote username and fragment that is different than the auto-latched username and fragment, and then it creates this weird state where you auto-latch with one remote username fragment but called start with a different one. And I do not know how to solve that particular problem.
Well, I guess that's what the event would be for, right, Robin?
Yeah, but even then, even if you had an event, there's no guarantee that the event just isn't sitting in some JavaScript queue ready for you, and you're still calling start at that time. So it can help reduce the window, but does not eliminate the window. So there's a problem. So next slide. And this is another possible solution to this problem, is to, instead of emitting an event on the transport where you have this auto-latching scenario, you have an event handler on the gatherer, which you still have to buffer with this scenario, but you have an event that happens that a new incoming check has arrived. You're not responding yet, but you have to call immediately afterwards on some ICE transport, respond to incoming connectivity checks based upon this this event that happens. And to give an example below, where you've received the remote username fragment and the remote role, and therefore before calling start, you can call some method like respond to incoming checks on a particular transport, where you specify the remote username and fragment and the role. So next slide. The good thing about that is it allows you to respond to the signaling beforehand. There is no race condition between the start and signaling because it's done in JavaScript, where you're exactly specifying which transport receives what. The bad news is it still requires some small packet buffering because, unfortunately, there is some setup time. So my question for you guys, and I want to particularly point out point 2 here, is that is either solution acceptable, is there a preferred one, And is it worth it, especially what Justin pointed out earlier, that many ice scenarios can't be set up anyway until you've completed round-trip signaling because pinholes won't open until you issue outgoing checks anyway. So you might have called the start anyway, so maybe this is a whole bunch of effort which isn't going to be worth it for a lot of scenarios. So just throwing it out there, this is what we've come up with, and what do people think?
I think that the first solution is nice in that for just normal one-to-one calls, it sort of just works.
You're breaking up, Robin?
Sorry, can you hear me?
That's not me, that's Peter, and he's coming in clear for me.
So I was saying that the first possible solution has the benefit that in normal one-to-one case, where you do a normal thing, which is create a gather, create an ice transport, and create a details transport, it just works. And there's really nothing fancy you need to do. And the main issue I see is where when the remote username fragment gets autofilled, how do you reconcile that with the remote user name fragment coming in on the signaling? Like, that situation's a problem for call forking, and I think we still need to resolve that. But if the call forking scenario is slightly more complicated and the normal one-to-one case just works, I think I'm in favor of that kind of approach, rather than having the one-to-one case not work properly or not work well unless you know some extra advanced fancy thing you have to do.
I would agree with you, but I question whether it's worth it at all in the first place, because I still think that there's going to be so many scenarios where this doesn't work. Like in the typical call-to-call scenario, where you got firewalls involved, and even for turn, it still won't work until you issue outgoing checks and open up permissions. So I don't even know if this is worth it, and this will only work, in my opinion, in server scenarios. So I don't know if this is even worth it to do at all.
Well, we're using a server-based communication system right now, so that's definitely a big enough use case.
Oh, it's a big use case, but is it worth it in the server case to do this versus just requiring that both parties call start?
I don't know, probably maybe Justin might chime in because he's more familiar with things like Hangouts.
Yeah, I mean, there's definitely a case where this happens. Was trying to recall the exact case.
From what we've seen is you see quite a few cases where signaling can go through quite an interesting path, different from media. So you get signaling quite a bit later. And then you actually end up with about 5 seconds worth of delay on the session setup.
Then that would suggest it is worth it if that is truly the case. Maybe.
In our previous decision we made, we decided to pass the gather into the transport. And in a normal one-to-one call, I don't see any downside to responding to the stun binding requests, since we already have passed the gather into the transport and we can respond to them. The big issue is just whether the remote username fragment that comes in was going to match the signaling, so we need to decide what to do when they don't match. But in a one-to-one call, a normal one, like, that's almost never going to happen.
Even in a one-to-one call, if you specify a different role than the one that auto gets filled, there is a potential issue, but obviously that one's easier to solve, just saying ignore the start role and you're too late. But yeah, I don't. The problem is that we do need a solution for forking if we do adopt that scenario, because otherwise we've broken forking as well.
Well, the other issue is where you get different UFrag is that if it's not a forking but a sequential call scenario, and you got initial call set up for call 1, and then you get the UFrag for the call 2, which kind of gotten to be the actual call being set up.
That's true, or a nice restart even.
Guys, I don't mean to be rude, but we're coming up on 15 minutes remaining, so maybe we should take this to the list.
This is our last major issue, Eric, so I'm not particularly worried. And this is pretty important, so I'd like to give it like 5 more minutes if you don't mind.
Okay.
Yeah, I like the first thing that you proposed, and I think the main, I agree that there is an open question as how often would this be an issue. I previously argued that in some of these cases we don't need to worry about it that much because it is like a pretty corner case. The one issue here is that I do think that if you miss this initial thing, the incoming check, well, it's going to try checking a lot of the other things instead. And until there's a trigger check or it gets around to doing a retry on the thing that would have generated the pure Fox candidate, it's going to cause increased call setup time. So that was our reason for having to dealing with this, in the first place. And I think that your first solution, is a reasonable enough way, given the complexity here, to deal with this without adding a lot more complexity for the average case.
I agree. Does anybody have an idea how we can solve the forking scenario for the other, so that the start doesn't mismatches from the auto latch?
Peter has an idea on this.
I had one idea. I don't know if it's good, but it might work. So if the ice gatherer had a method that was something along the lines of get or create transport, and you passed in the remote username fragment, then it could return one if there is one and create one if there isn't. And then you wouldn't have the race condition where you're checking and then creating one, but then a packet comes in right at that moment. That's kind of the best I could come up with, just to avoid that read, check, create, but then there's a problem between the read and the create.
So basically what you're proposing is a factory method, a static factory method, so not a constructor where you would it's kind of like a start, but except it constructs or it returns an existing one.
Yeah, on the gatherer.
It's not a horrible solution. I've heard worse.
That's quite the vote of approval there.
It's not the worst solution. I'm not sure the actual race condition exists, just due to the way JavaScript operates, because you can essentially you can be checking and creating doing in the same path.
It's definitely going to exist because I mean, at least in Chrome, the signaling is going to be on one thread and the network work is going to be done on a different thread. Okay. And so when one thread's responding and adding these and auto-filling these remote UFrags, then on the JavaScript's not going to know when that's happening. So there needs to be some way of doing an operation on the same thread that the network work is being done on behalf of the JavaScript.
Under the same look, I guess. You're going to be doing it from JavaScript thread anyway, and just look to the network thread for that time.
I know in my implementation I will definitely have a race condition as well. I'm presuming Chrome is going to have the same issue because we're based upon the Chrome engine. So, yeah.
Then factory method would be better than for that.
Yeah. I think that, can we get consensus that everybody likes, method 1, but on the presumption that we have a solution for the forking problem, and obviously, let's take that solution to the list, and we can start with Peter's solution and see if somebody can come up with something better. No offense to the idea. I actually think it's.
I'm not completely sure about it myself. I kind of wish I could think of something slightly better,
But given that it is kind of a more complex scenario for forking, that doesn't sound completely unreasonable.
One thing I want to make sure is that scenarios where you end up with a mismatch of UFrag between what auto-latch and what you set on the start, that it's resolved in some sort of reasonable way, even for basic scenarios, because otherwise it can create some interesting corner case bugs for developers that they won't normally expect during testing and might run into in the
Yeah, I agree that even if we do come up with a solution for the call forking, we do need to have reasonable behavior for when we autofill the UFrag, but we also pass in something that's different, like whether we decide that throws an exception to the JavaScript, or whether it just has a particular behavior that the ICE transport takes on from that point, something along those lines.
Yeah, I don't have the answer to that. So does everybody at least like the idea, and then we'll come up with the answer to the second problem? So, or do we want to, should we come up with the full solution before we agree to even the partial?
I think we need to see where it will lead us, because we might kind of end up with a situation where we will, once again, where there is no resolution, even though the simple problem seems to be solved. More complex one becomes almost unresolvable. But it looks like a reasonable direction to pursue, at least for me.
Any other feedback?
I'll send something to the list with some sample code that says, here's what it could be, and see what we think.
Okay. Thanks, Peter. Yeah, this is our last issue that we're going to discuss today, and hopefully it's a simple one. Notice during implementation that we could not calculate the priority field on a candidate from just the gatherer as it currently stands, because one of the values, according to the recommendation of the RFC in the calculation, is the component ID, and the component ID is 0 for RTP and 1 for RTCP, but there is no component on a gatherer right now. So the solution that I had is basically, or is proposing, is that similar to the create associated transport that exists on RTC ICE transport for this very reason, that we have a create associated gatherer on the gatherer, so that there is a component to the gatherer, so therefore we can calculate the priority properly. I don't have an alternative solution, and I also don't think that this is really a bad thing, but I'd like to hear feedback on that.
So the typical case here would be you're setting up a transport, and right now you would just create two gatherers, one for RTCP and one for RTP, right now.
Correct.
And
If we had this on the gatherer, and then you passed in the gatherer to the transport, would you even need to have get associated transport and a component on the transport? Couldn't it sort of like inherit the component of the gatherer? I mean, what if they mismatched? What would you do?
Well, a mismatch is basically an exception. You have to do it right if you're going to do this. But in terms of your original question, could you perhaps derive some intention or this thing? Probably, yes. We'd have to look at that as a separate issue, because it might be possible to optimize some of that out then for the transport.
yeah, I like Peter's suggestion. That it worries me a little bit that you could get out of sync. And also, like, what happens if you call create associated gatherer on a gatherer that was already an associated gatherer?
Well, the same thing that would happen on the transport, we throw an exception in that case. You're not allowed to.
Okay.
So if you do anything wrong, you're going to throw an exception if you mismatch.
Yeah, I'd like to understand if it would be possible to do this where you wouldn't have to use, where this would allow you to avoid having to have create associated transport. It sort of seems like we're just moving that choice earlier, and that might allow us to, instead of adding a method, to just move a method.
The other option is just to specify the component that you were creating the gatherer as.
Sure, but I think that's just like, is the method red or green or blue? I mean, like that's kind of like, what's the syntax for it? I think the real question is, architecturally, do we need two methods for this and the transport creation, or can we just have one? And then either way is fine. What I meant by that was that once we decide on that, whether we take a component or whether we have the method to create an associated gatherer, I think that's just a matter of taste.
Well, if we're actually going to create a static constructor on a gatherer to create the transport, then the problem is kind of self-resolved based on the previous discussion, because the transport is created from gatherer.
Right. If the transport takes a gatherer in the CTOR, then this problem, I think, is resolved.
No, it's not. Because even then, there is the candidates can get emitted before the transport is attached, and you still need to calculate the priority of those.
No.
So I think Justin was saying you don't need it on the transport if the gather is passing into the transport.
Yeah, that's what I was trying to say.
Oh, right. Yeah. Okay. Sorry, misunderstood. So does anybody have an alternative to this aside from the flavor, whether we accept the component or the method that they'd like to propose, or have an idea how to fix this problem?
I like this proposal here just because it makes the case where you're doing RTCP mux the simplest case. You don't have to pass in anything. And if you are not doing RTCP mux, you have to do a bit more work. And that's how it should be.
In that case, we could also add a few more methods to make it harder not to do RTCP mux.
Yeah. Okay. Do we have consensus on what Justin's proposing there, or just said? Okay, I agree with what Justin just stated.
So for the note consensus on having the second method, is that it?
Yes, and making it harder for the people trying to do non-mux scenarios.
Right.
They have to have the other method, and we can look at removing this method from the transport because it seems, unnecessary there.
Okay, with that in mind, another general question to the CG. Are there any comments regarding the current API, which you can find at ortc.org? I think it was posted on May the 5th. I'm not sure when you guys put it up, Robin.
So next time we're going to cover when no encodings are passed into the send parameters, right? Or the receive parameters, or both? I saw that on the coming actions.
I'd like to. We didn't have time to do it for this today, unfortunately. I wanted to do it for today. And it also takes considerable effort to explain how that even works.
Yeah, understood. That's next time, okay.
Yeah, I'd like to do it soon.
The other is, are we going to cover Philip Hinkey's comments on the list or in the meeting, or
if anybody's actually read them, that would be, I'd love to talk about it.
If someone can make it in a format that I can actually read, I would appreciate that.
I think
in some way that doesn't require Adobe Acrobat Reader.
Emil, can you talk to Fippo?
About making him transform
his comments regarding the most recent API.
Created this lovely PDF highlighted thing that can only be looked at from Adobe Acrobat Viewer. So,
okay.
But I do appreciate his effort to doing so. Just like to be able to read it for everybody.
So just to make sure I understand, the Adobe, so the PDF thing is the problem.
PDF thing isn't readable by everybody because you have to see the comments for a lot of viewers. You have to actually install the Adobe,
okay, got it.
the Adobe, and that's the issue.
Yeah, you have to load Adobe and then reveal the comments. They don't even reveal themselves, so it's kind of
Yeah, you can click on
intuitive.
you click on the highlighting, and it doesn't even show you an option to say, "Hey, what's this about?" So it just looks highlighted all over the place.
I'm trying to find them here just so I can show what we're doing.
I did read through his comments, and there are some things that are valid, like our ordering of our objects and our spec is a little bit funky, that they don't seem to follow any logical pattern. It's just random objects specified all over the place.
Yeah, I think I understand Peter's
yeah, so you view it here.
Issues here. You can see it in the in the browser as a PDF reader, but you can't actually reveal the comments. So it means you have to boot up Adobe.
Yeah, you have to download it and then save it to disk, and then load it in Adobe to be able to see it, which isn't ideal.
Especially if you're on a Linux machine.
Good point. And there's a lot of comments, so to go through it today would be impossible.
Yeah, I'm just trying to find an easy way to convert it myself. But anyways, I'll take that off list.
We should go to the next slide because the next slide is important. And Bernard, can you mention something there? If you're still on the call.
Slide to load.
Yep, here it is. Stefan, I threw this in here because Stefan asked us to talk about this, but we don't have to spend a bunch of time on it. EDN capture and streams working draft requires a bit of comment, so if you guys want to go check that out and provide some comment. Does anybody have anything to say about that on the call? No? Okay. Bernard, what is it that you wanted to speak to?
I don't know, Robin.
Oh, I didn't realize it was you, Eric. I thought Bernard threw that slide in there.
No, I did.
Okay, then I'll speak to the next slide. Mobile ORTC C++ implementation is heavily underway. So you're welcome to take a look at where we're at. In there, we've got some ICE implemented according to the latest ORTC specification, and the JavaScript shims have not been touched. It's a vacant repo, so if somebody wants to start taking up that effort, we're happy to see that underway as well. And the ORTC specification is linked there, so you can see our commits and what we're doing there. Love to see some node implementations going on if someone wants to take that up as well. And just to mention that there are browser implementations underway as well. Modern.ie status shows in development, so we're looking forward to Microsoft's implementation of ORTC as well. This is why it's really important to get a lot of these issues resolved as quickly as possible, because we're running into them in development, and I'd love to see them solved so that we can have some good implementation feedback and give this ORTC API a true run in the wild.
Okay, so this is basically reiteration of what Robin just said, and in addition to that, you can join the ORTC community group via the W3C community group link. Special thanks to Bernard, Michael, Champion, who's not on the call today, Justin, Peter, Robin, and Emil for scribing and for trying to get us going with Jitsi. Thanks, Emil. I appreciate all your help.
We'll work next time.
Okay. Here's some links, and I think that concludes the meeting. Thanks for everybody for joining and putting up with our problems today.